Good morning, students. Am I audible? Very few attendance. What about the others? They are joining. Okay, so we will be waiting for another 2 minutes. Okay. Okay. So you kindly write down the next question. This is our next numerical. Okay. So it's not properly visible. Okay. So here you write a question. Okay. If y1 and y2 are alternate depth in a rectangular channel, so that if yn and y2 are alternate depth in a rectangular channel, so that then we have to prove this expression. Okay, that yc cube is equal to twice y1 square y2 square divided by y1 plus y2. So that yc is nothing but our critical depth, and we all know if y1 and y2 are the alternate depth, that means the specific energy with respect to y1 and specific energy with respect to y2 will be same. Okay, because here it mentioned yn and y2 are the alternate depth. Okay, you write a question that if y1 and y2 are alternate depth in a rectangular channel, so that critical depth, that is your yc cube, is equal to twice y1 square y2 square divided by y1 plus y2. So this we have to prove, and the second part of the question is we have to again prove for specific energy also, that y1 square plus y1 y2 plus y2 square divided by y1 plus y2. Okay, So what the question says, if your y1 and y2 are two alternate depth in a rectangular channel, then we have to prove that our critical depth cube is equal to this expression. And for specific energy is this expression. That is your y1 square plus y1 y2 plus y2 square divided by y1 plus y2. Okay. So we move on to the solution. So as I have already discussed, if y1 and y2 are the alternate depth, that means we have same specific energy for both the depth. Okay. So that is why we have considered E1 is equal to E2. Okay. So E1 is equal to E2. So for E1, we are going to consider the depth Y1. Okay. So we are going to write the specific energy equation here. So we all know in the specific energy we will be having only two terms. One is Y and one is V square by 2G. Okay. V square by 2G. Okay. So as we are considering that E1, so this depth will be 1. Okay. And that velocity will be V1. Okay. This will be your y1 plus v1 square by twice g is equal to y2 plus v2 square divided by twice g for E2. Okay. So as y1 and y2 are the alternate depth. Okay. So we are replacing the velocity by q by a. Okay. So that is why y1 plus q square divided by a1 square, because here the depth of flow is y1. That is why a1 square twice g is equal to y2 plus q square by a2 square twice g. Okay. We are replacing velocity by discharge divided by area. Okay. We are replacing velocity by discharge divided by area. Okay. And if you remember, our small q is nothing but discharge divided by width of the channel. Okay. So in place of discharge, you can also write small q multiplied by capital B. That is your width of the channel. Okay. So after this equation, then we are replacing this q value by this equation, small q multiplied by width of the channel. So that is why that q is square is there. So that is why it's small q square b1 square, and here also small q square b2 square. Other terms will remain same. Okay, so you write down till here. Over. Okay, so then we proceed to the next. Okay, so we are replacing that discharge by small q multiplied by b. Okay, after that, so we all know for rectangular channel, we have already derived this expression that yc is equal to q by twice g to the power 1 by 3. Okay, it's q square by twice g. Okay, q square by twice g to the power 1 by 3. Okay, so or you can also write this equation is like this: yc cube is equal to q square by twice g. Okay, so after replacing that discharge value, okay, our intention is to find out the expression for qcq. Okay, so we have to bring that use yc in this particular equation, because if you see here, we don't have any critical depth here. Okay, so we have to bring the critical depth here, then only we can find out expression for this. Okay, so always whenever you are going to solve a numerical, always see what is given and what you are going to find out. Okay, so our aim is to find out an expression for yc cube. Okay, our aim is to find out the yc cube, so we have to bring that yc cube in that particular equation. Okay, then only we will get this expression. That is why after replacing that q value by q square multiplied by b1 square, then we have to bring that yc value. Okay, so yc cube is nothing but q square divided by g. Okay, q square divided by g. Okay, not twice g, I did mistake. So it's g only. Q square divided by g for rectangular channel. Okay, so here we have q square here and we have g. Okay, so in place of q square by g, we can write yc, and other term will be left. Then b1 square divided by twice a1 square. Okay, b1 square divided by twice a1 square. Okay, only q square by g, in place of q square by g we have written yc. So here also q square by g, in place of q square by g, yc. Okay, After that, we are going to replace that area by b into y, because in the question it's given it's a rectangular channel. Okay. So in place of area, we are going to write again b1 into y1 square. As area square is there, so it will be b1 square y1 square. Okay. So this b1 square and b1 square will be cancelled out, and similarly here also. Okay. In place of a2, we are going to solve that, break that area by b2 multiplied by y2. Okay, but square is there, so that is why b2 square multiplied by y2 square. Other terms will remain same. Okay, so here if you see that b1 square will be cancelled out, what will be left out is y1 plus yc cube divided by twice y1 square. Okay, and plus y2, here also b2 square will be cancelled out, and left out will be yc cube divided by twice y2 square. Okay, done. Okay, so here that after this equation, we have already discussed till this expression. Then see, we are going to take LCM here, and we are trying to find out. So it will be multiplied. So twice y1 square multiplied by y1, so it will be y1 cube plus yc cube. Okay, divided by twice y1 square. Okay, similarly here also we take LCM and we solve. Okay, there is y2 is there, and here y2 square, so it will be multiplied. So twice y2 cube plus yc cube. Okay, this is simple mathematics. So this 2 and this 2 will be cancelled out. Okay, this 2 and this 2 will be cancelled out. Then you cross multiply. Okay, then you cross multiply, cross multiply, and see what you are getting. See here 2 and 2 will cancel out. So what will be this? We are multiplying this part with this. Okay, so that is why twice y1 cube is there, then y2 square. Okay, then plus yc cube multiplied by y2 square. Okay, is equal to, you have to multiply it by this with this expression. Okay, so it will be twice y2 cube and then multiplied by y1 square plus yc cube multiplied by y1 square. Okay, so after this we are going to bring that yc, because we need to find out an expression for yc cube. So we are going to bring that yc cube in left hand side. Okay, so here You see yc cube y2 square, and we have another term with yc cube is this. Okay, so if you bring this into left hand side, it will be minus, because here it is positive. So if you bring it in the left hand side, it will be negative. So if you take common yc cube, so it will be y2 square minus y1 square. Okay, is equal to, so it will be left out with this term twice y1 square or y2 cube, y1 square y2 cube, minus, if you bring this term the right hand side, it will be minus. Okay, because here it is positive. Okay, if you bring it here, it will be negative. Okay, then yc cube, then it will become divided by this. Okay, so here, if your a square minus b square, a square minus b square, you can write like this: a plus b and a minus b. Okay, this is simple mathematics. Okay, a square minus b square, you can write a plus b and a minus b. So here you consider this is a and this is b, so it will be, you can write a plus b and a minus b. Okay, here also in this part, you take common twice y1 square y2 square. What will be left out is y2 minus y1. Okay, in that equation, and if you bring this here, you can use this equation that a square minus b square is equal to a plus b multiplied by a minus b. So these two terms will be cancelled out. Okay, okay, and you are going to get the final expression as this. Okay, this is the expression that twice y1 square y2 square divided by y1 plus y2. So it's a plus b or b plus a is same thing. Okay, 1 plus 2 or 2 plus 1 is same thing. You can write y1 plus y2 or y2 plus y1. So do you have any doubts regarding this derivation? Yes, I think it's very simple. Only you have to use, because that in very beginning in the question it's given that y1 and y2 are the alternate depth. So we understand that the specific energy will be same. So you equate both the specific energy and you try to bring that yc value, okay, that your critical depth for your rectangular channel, and then you solve. Okay, other things are very simple and the simple mathematics. Okay, so if you solve, then definitely you will come up with this equation. Okay, so that first part is over. Then we have another part that we have to find out an expression for specific energy also. Okay, so then we are going to take this specific energy equation. Okay, specific energy, that y1 plus v1 square by twice c. Okay, so again that v we are replacing by q by a. Okay, similarly that we did in previous case. Okay, that velocity we are going to replace by discharge by area. Okay, then we replace that discharge per unit width is q. Okay, so discharge is equal to p into q or q into b. Okay, same thing. So then we are going to replace the discharge by q into b. Okay, in this previous case how we have replaced the discharge. Okay, then again we bring that yc value, that yc cube or a rectangular channel is nothing but our q by g, q square divided by g. Okay, so that q square divided by g, we bring yc cube, b1 square will be there divided by twice a1 square. Okay, okay, other terms will be remain same. Okay, then again this will be yc cube, we replace this area a1 by b1 into y1. Okay, because it's a rectangular channel is given, multiplied by y1. Okay, okay, so it will be square, so it will be b1 square multiplied by y1 square. Okay, so that b1 square will be cancelled out. What will be left out? Yc divided by twice y1 square. Okay, okay. After this, this expression, that yc cube y1 plus yc cube divided by twice y1 square, we have to replace that yc cube by using that expression that we have already derived in previous case. Okay, so that yc cube expression we have to replace here. Okay, that we have derived in the previous case, and yc cube is equal to twice y1 square y2 square divided by y1 plus y2. Okay, that expression that we have just now we have derived for the rectangular channel, that we have to replace, substitute here in place of yc cube. Okay, so it will be twice y1 square y2 square divided by y1 plus y2. Then this is will be there multiplied by twice y1 square. Okay, so this 2 and this 2 will be cancelled. Okay, then you again take LCM and you find out the expression. It will be y1 square, this will be y1 square multiplied by y1, it will be y1 cube, and then we have this also multiplied by y1 plus y2 plus y1 square y2 square divided by y1 plus y2 y1 square. Okay, then if you break this bracket, it will be y1 to the power 4 plus y1 cube y2 plus y1 square y2 square. Okay, and in denominator y1 plus y2 y1 square. Okay, if you think we have discussed till here. Okay, so after that if you see here y1 to the power 4, then y1 cube, then y1 square. So from here we can take a common of y1 square. So it will be If we take out y1 square, it will be y1 square, because here it will be y1 to the power 4. So it will be y1 square plus y1 cube is there, so it will be y1 y2 plus again y1 square we have take it out. So what will be left out is y2 square. Okay. So this y1 square and here we have y1 square, it will be cancelled out. Okay. Okay. So this is the expression, final expression for specific energy. So we are almost towards the end of this unit. Okay. Only we have one thing is need to discuss, that is your specific force. Okay, this is a very small topic, and then we have a derivation. Okay, so the derivation part we will do in the next class. Okay, derivation part we will do in the next class. Only the derivation is left out. Okay, so we'll do the derivation in the next class, and then we move on to the next unit. I think it will be in next week. I think. Okay, it will be in November. Okay, so with that derivation, this unit will be over. Then you will be left out with only two units. One is your gradually varied flow, and I think one is another one is hydraulic jaw. That is your rapidly varied flow. Okay, so don't worry, we will complete our syllabus within 15th of November. Actually, that college will open from 2nd November only for staff and faculty. Okay, for students there is no such circular till now. Okay, so you people will be having your class online only. Okay, till further notice. Okay, So from 2nd November, that is this college will open only for faculty and staff. Okay, so you can write in down this topic, that is specific force. It is very much similar to your specific energy. Okay, only the graph is little bit changed. Okay, we don't have that E is equal to Y line. Okay, so here also Y, in Y axis we have depth, and in X axis we have force, that is specific force. Okay, and other terms are all are same. Okay, and then for particular discharge in a particular channel, you will be having one curve. The pattern is very much similar to your specific energy curve. Okay, okay. So then this minimum specific force is also for critical depth. Okay, like your specific energy curve. Okay, and minimum force for that particular depth is critical depth. Okay, then if you change the discharge, then if you join past straight line, then again it will be divided into two half. One is supercritical zone, one is subcritical zone. It is very much similar to your specific energy curve, only that E is equal to Y line at 45 degrees there in specific energy curve, which is not here in specific force. Okay, others all are same. So you can draw this diagram later on also once I will give you this PDF. So that second discharge curve will this side or that side, it depend on the discharge. Okay, if it is more, then it will come here, or if less, it will go below that discharge. Okay, so suppose if it is a 15 and it is, then it will be increased to 20, then it will be like this. Okay, so you can write down the definition. Specific force is defined as the sum of momentum of flow. Specific force is defined as the sum of momentum of flow per second per unit width, and is also called force per unit weight. Specific force is defined as the sum of momentum of flow per second per unit weight, and also it's called force per unit weight. Okay? It is denoted by capital F, and you can write down this expression. Okay, F is equal to Q square by VA square plus AX bar. Okay, it's AX bar, X bar. So what it says, that specific force in two section. Suppose if this is your river cross section, this is the bottom of the channel. If you consider two section, one is here and one is here. If you consider two section, one and two, specific force in both the section will remain same when the slope is very small or zero. Okay? If the slope of the channel is very small or very, or it is zero, then you can say that specific force for both the section is same. Okay, and also if the frictional force is neglected between the two sections. Okay, definitely that friction force cannot be zero. Okay, you are going to consider or not, it depends on you. If you don't consider, or if you neglect that friction force, that then we can say that specific force for both the section is same. Okay, so this is all about your specific force. In the next class, we discuss the derivation, and then I think we'll be having two classes in the next week. So in first class, we are going to derive the equation, and then we will move on to the next unit. Okay, so we are going to end today's lecture here. If you have any doubts, you can discuss now.